part 3 of the tutorial. Just wanted to wrap up with a couple things. UDFs and joins. UDF stands for user defined function. Again, the demo data is here at this link. Thank you to Loonicorn, Genevieve Revive for that simple data. And then here's the GitHub that I have for this tutorial, Kevin Currick, so you can follow along with this notebook. If you want to just poach the code, that's fine with me. So a couple things I'm going to do is in this tutorial, we're going to look at player data and player attribute data from soccer players or football, depending on what side of the world you're on. And I'm just going to import the data and just show you how to join a couple things and teach you how to, make a new column and rate players, things like that. So first I'm going to import player data. So that's the player's data. You can see here's the high level what it looks like. And then here's the player attribute data. This guy is much too big to actually show. So I'm just going to print the schema. As you can see, there's a lot of attributes like short passing and dribbling and their curve and their free kick accuracy, right? So I'm going to subset that guy down quite a bit. In the initial players data, I'm just going to drop a couple columns. In this guy, I'm just going to drop ID and player FIFA API ID. And then in the players, I'm going to select only a couple columns that I care about: the player API ID, the date, overall, blah, blah. You can see. So this big schema becomes this guy essentially once I pare it down with some select, and then I do a drop NA, just make sure there's no missing records happening. From there, what I'm going to do is I want to determine the player rating based off of 2016 only. And so right now I have this date, but I really just want the year of 2016. And so there's two ways to do this. First, I'm going to do it the hard way, which is the way you probably should not do it if there's a built-in function, but I'm going to show you what a user-defined function is just in case you really need it. So first, let me comment this guy out because we actually won't use this guy. And then I'm going to use this guy right here. Right here. Let me rerun this code really fast just to make sure that I have it uploaded correctly. So what is a user-defined function? It's basically just a way to tell Spark, hey, I'm going to write some code that you currently don't have built in, but I'm going to write some basic Python basically to specify how I want a function to run. So you can see that I'm creating a lambda function here, and I'm just saying x.split and grab me the first column. So I know that this x is going to be my date when I apply it to the with column. So I'm going to, and then I also have to specify the UDF functionality around it. So it's basically, hey Spark, this is going to be a user-defined function. This is what I'm writing in Python. You're going to need to apply this to your Spark data frame. So when I apply the UDF, I'm going to do the with column like I did in the other tutorials to make a new column. I'm just going to name it year. And then I'm going to name it year UDF, which is the function that I had created with the lambda. And I'm going to write that on the player attributes, the date. So from there, the date is only going to grab, it's going to split on the dashes, right? And it's going to grab the first element, which is 2016. So you see that when I run it, I get the years. I only get the years specifically, which is nice. Now, that's a long way, especially when Spark already has a built-in feature to grab the year out, and I'll show you how to do it, what is in this case the right way, but I just wanted you to know that UDFs exist for custom functionality. So if you want to do the built-ins, again, let me run this data just to get it back to where it was at. And so now what I'm going to do is I'm actually going to use the PySpark SQL functions and import year. So from a date, you just use the year function and it just grabs it right for you. So you can see I did the with column. Again, I named it year, and rather than using the year user-defined function, I'm just going to wrap year around the date column. And you can see that when I run it, same thing happens. So that's obviously the better way to go in this instance. Obviously, there's other times where a user-defined function is better. And then I drop the old date, so that way I only have year left in the frame. So now what I want to do is I want to find the best striker in 2016 with joins, and one of the data frames, as you can see, this player attribute only has a player API ID. So eventually I need to merge the player data frame with the player attribute data frame, so that way I can find the actual names of individuals. So the first thing I'm going to do is just filter on 2016 just to keep the data manageable. And then I'm going to count the number of distinct players. I just was doing a basic count. There's about 5,000 unique individuals. And then I want to aggregate by the attributes that I guess I care about in determining if a striker is a good individual. And so I only am looking at their finishing, their shot power, and their acceleration. And what I'm doing is I'm writing an aggregate. I'm doing the average of all these guys across all the years or records that they might have in 2016. So from there, I am going to just rename the averaging columns, finishing, shot power, and acceleration. And then what I'm going to do is I'm going to weight each category differently. So I want to say that shot power is twice as important to me as finishing and acceleration. I'm going to establish a total weight. And then what I'm going to do is, in order to determine the grade of the striker, I'm going to make another column, right? So with column striker grade, and what I'm going to do is the finishing power times the weight finishing, which is just 1, the shot power times the shot power, which is 2, and then the acceleration times the weight acceleration, and then divided by the total, right? Just to get like some legitimate average. I'm going to drop all the columns I don't need anymore because now I'm just going to have striker grade. And then I'm just going to filter on strikers above 70 and order in descending form just so like I can visualize it. So right now I get a player API ID and a striker grade, but I don't know who they are, right? So all I need to do is merge on the unique key between player and player attribute. So all I'm going to do is it's going to look very pandas like a df.merge or a pd.concatenate. I'm going to name it details as a new data frame. I'm going to do the player's attribute or the player's data frame, and I'm going to join it with the striker's data frame, and I'm going to join it on the player's API ID equals the striker's API ID. This is exactly like the pandas merge or the PD concatenate, and so they both have the same unique ID, and so you technically don't even need to name strikers and players in the front piece, but it's just good to be explicit. I'm going to do an inner join. And then I'm going to do the details order by and then striker grade. So now you can see when I actually pull the data frames together, I get the player API ID, the player name, their birthday, their height, their weight, the player API ID again, right? I could obviously drop these guys because I pulled it from the same data set. And then the striker grade is all together. And so obviously the best player in the game is the Hulk. Probably not a surprise there. I think he's going to win most soccer matches or most physical contests that we know of in the universe. Anyways, guys, I appreciate your day. Have a good one. Thanks. Bye.